Good morning, class.
Good morning.
Okay, so if you remember yesterday, right at the end, we just got finished talking about the difference between AC and DC and what a circuit is, okay? So before we go over that, what I want you to do is take your paddles, everyone get your paddle, okay, and I want you to draw me a circuit with, I don't know, light bulb in it. Draw me a circuit with a light bulb in it. That would actually light up. You got 20 seconds.
Power source. Yeah.
This big a light bulb?
Oh. Okay.
Okay.
All right. Stop. Very good. Okay. I like yours because that's what an engineer would draw. But actually, would you mind if I took yours for a bit? I'm going to just copy yours up onto the chalkboard. Thank you. Okay. And so I like this one because it really sends home the idea that a circuit is when electricity can flow from a positive voltage to a negative voltage. And really by positive and negative, what we're talking about is high voltage and low voltage. Okay? Now, so I'm going to draw that. I'm going to draw a little box up here. We're going to call that our power source. And we got some wires and a nice light bulb with a filament. Fantastic. Thank you very much. Now, so who can remind me what the difference is between an AC power source and a DC power source? Alternating current versus direct. Do we remember the pearl necklace metaphor? Okay, well we can go over it again. In a DC power source, you can imagine a bunch of little pearls, which are the electrons, all traveling in a circle from positive to negative around our circuit. They go through the filament, heat it up, and that's what gives us light. Now an AC circuit, it does it slightly differently. Instead of pushing this guy all the way around, instead it shakes the pearl necklace around the circuit. So this little electron will vibrate back and forth. But that still heats up this filament and still creates light, so you can use both. Now, you know what, before we play with that, let me ask you guys something. What happens if I do that? Cut off the wires, what happens?
The light bulb turns off.
Why?
Because there's no power.
There's no power, but there's power right here.
But it's
It's
not
not
connected to the light bulb.
It can't flow. That's right. What does it mean for power to flow?
Moving it
Travel.
Travel from
That
high
means-
voltage to low voltage.
Traveling from high voltage to low voltage. And let's demonstrate that right now. In fact, since you're so on top of this, why don't you come over here?
Oh, really?
Yeah, really.
Come on, teach.
Yeah. Okay. There we go. Okay, so this is an AC power source. It's called a Tesla coil. Okay. Now I'm going to, I think I'll let you use this one, but I'm going to touch.
Oh, cool.
And you can see this AC power source lights up this little light bulb. Okay? Now I'm going to cut the wires off. And you can see there's a volt of electricity that's jumping from the AC current, from the AC source to this light bulb. Get a little nervous?
Yeah.
Don't be, this is AC, it can't hurt you. Or, well, it can, but not at this level. All right? But you can still see there is flow of electricity going up from here to the light bulb. It's still shaking those electrons. But now if I move it up here, you can see there's no visible electricity, and yet it's still lit up. An even more dramatic example, and this is where you're going to come in.
Oh,
No, don't worry. No, there's no danger at all. Okay, what I want you to do is I want you to start up here, and I want you to lower it down. A little bit more this way.
Ooh, look at that.
Take a look. No physical connection at all. None at all, guys. And so the point of this demonstration is, and I'm going to demonstration, guys, is that you don't need a physical wire to carry an electric field. You don't. This battery would need a wire normally because traveling through air is hard for electricity. But if you have a strong enough electric field and one that's moving back and forth like an AC current, you really don't need anything physical holding them. Who can give me an example of this in play? The radio in your car, okay? That's a circuit. And that's all my time, thank you.